Okay, as we transition from SOHCAHTOA version of sine and cosine to x and y coordinates of sine and cosine, we're going to transition on to the actual sine and cosine waves. I want to show you that they are really pretty interconnected here. So here, on the right hand side, I have a unit circle, and I'm going to go ahead and label some degrees just so that we have a good starting point. This is 0 degrees. My pen will work. This is 90 degrees. We have 180 and 270, and I'm going to go around again. This is 360. This is also known as 450. My pen's acting kind of funny. This is 540 and 630, and again we could come back to 720. Now why did I do that? Because I want to fill out this table here, right? And if I can go around the circle with degrees, that's great. And I know that my ordered pairs x comma y are, or on the unit circle, are of the form cosine theta, sine theta. Okay, so let's do this. I'm going to go ahead and just read out the cosine values. Those are the x values as I go around the circle, right? Cosine of 0 degrees is 1. Cosine of 90 degrees is 0. Cosine of 180 is negative 1. Cosine of 270 is 0. And now I go back around again. Cosine of 360 is 1. Cosine of 450 is 0. Cosine of 540 is negative 1. Cosine of 630 is 0. And then back around to cosine of 720, that's 1. And cosine of theta is actually a periodic function. You'll notice that this pattern repeats, right? It goes 1, 0, negative 1, 0, and then 1, 0, negative 1, 0, and that corresponds to 1 revolution around the circle. Alright, let's take a look at sine of theta. Okay, those are the y values. I'm just going to circle them just to make life a little bit easier as we go around. Sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is negative 1. Back around again. Our periodic function repeats. Sine of 360 is 0. Sine of 450 is 1. Sine of 540 is 0. Sine of 630 is negative 1. And back over to sine of 720 is 0. So that's the basis for how we're going to draw our sine and cosine waves. In case you ever forget what they look like, you could always go back, make one of these tables and draw your unit circle and just pull off the x and y coordinates to fill it out. So I have gone ahead and copied down parts of our table and made another coordinate grid. So notice here that I have my angle theta and my cosine theta values. So actually our x-axis is no longer x, it's actually theta. These are my degrees, okay? And then my y-axis is actually cosine of theta, okay? So these are my x coordinates and these are my y coordinates, okay? And so when theta is 0, my y value is 1, this is 1, and this is negative 1, and this is 0, just so that we're clear, right? At 90 degrees, my y value is 0. At 180 degrees, my y value is negative 1. At 270, my y value is 0. And at 360, my y value is 1. And as you're going to see in the handout we're going to do in class, these sinusoid graphs, they're not straight, they're curves, right? They're waves, right? They're sinusoidal waves. And so these are actually really rounded. But this is what a typical cosine wave looks like in standard position. Notice that it starts high, it dips down, so it's like a valley, right? It starts high, dips down in the middle, and then ends high. Notice that the y values go from negative 1 to 1. Okay, and then if I wanted to, and my grid went on, I can just keep on going and draw the next period. Okay, but this is one period of cosine. It has a period of 360. So cosine of theta has a period of 360. Okay, and it starts at 1 and ends at 1. This is the default cosine before it's transformed. All right, really quickly, let's go on to sine. Okay, you'll see here that I copied down parts of the table where my x is my theta again, and my y values are my sine theta. So this is the theta axis, and this is the sine theta. Alright, so notice that this is different. When x is 0, sine is 0. When x is 90, sine is 1. When x is 180, sine is 0. When x is 270, sine is negative 1. And when x is 360, sine is 0. And so, this has the same basic shape as cosine, but notice that it starts in the middle and ends in the middle, right? It starts in the middle, it goes up, back through 0, down, and then back up to the middle. Again, sine of theta has a period of 360 degrees, and the range is -1 to 1. Okay, actually, let me just mention this, but the domain and range, sorry, the domain of sine and cosine is all real numbers, right? Because I could go around the circle infinite times in either direction. So there we have the graphs for sine and cosine.